All right, so it's been a pleasure working alongside Alec, Benedict, and Jack McTasney this summer. Both study electrical engineering at the University of Vermont and enjoy grappling with complex problems. As classmates, they took a strong collaborative approach this summer where any obstacles were presented from the project with thoughtful consideration and clear solutions outlined. I greatly valued their drive when it came to reading program documentation, troubleshooting error messages, and data engineering tasks that sometimes lack excitement but are very critical for success in the project. And this project, which they'll discuss in just a moment, is one that Burlington Electric and many other electric utilities in the industry have been eager to solve, as the benefits include a myriad of things such as decarbonization, electric grid efficiencies, and program equity. Alec and Jack made great strides in advancing this project, and their work will lead to tangible change in the city of Burlington. On behalf of BED and myself, thank you, Alec and Jack, for your exceptional work this summer. The floor is yours.
All right, thank you, Freddie. Like you said, I'm Alec Benedict.
I'm Jack McTasney.
And this summer, we had the privilege of working with Freddie at the Burlington Electric Department. Next slide, please.
So in Burlington Electric's pursuit of net zero energy, or NZE, there are three primary sectors they're looking at: generation, heating, and transportation. And a large amount of effort has gone into electrifying the transportation sector. However, a huge consequence of this is the balance of supply or generation and demand or load has become much more complicated as charging these electric vehicles take up a large amount of energy.
So one solution to this problem is a method called flexible load management. And we were specifically applying flexible load management to level 1 EV chargers. So the city wants to increase the amount of EVs on the road. However, not everybody can afford an expensive level 2 charger, or maybe they're a commuter in the city and they don't need the full level 2. So we were focusing on using flexible load management to implement a level 1 EV rate where customers can get decreased costs in their electricity for charging their car. Next slide, please.
So this here is a simple overview of the level 1 pilot program as we see it. How it starts is a peak in energy usage is discovered by Burlington Electric using energy forecasting. And then we branch off to one of two methods, Shelley and Smart Car, which we're going to talk about in the next slide. Either of these will turn off level 1 electric vehicle charging during these peak events.
So then we have also, we're using Shelley and Smart Car to not only control the charging, but also to meter the energy data. So we can then use that data to generate an electric bill credit for the customer, which will then save them money. By controlling when the car is charging, we're going to manage the grid load to keep things balanced. The increased incentives for EVs will both be equitable. So anybody within level 1 or everyone with a 120 volt outlet can use a level 1 charger. And then the increased EVs will lead to decarbonizing the electric vehicle, or decarbonizing the transportation. Next slide. Sorry.
So Shelley is a smart home appliance company that develops smart appliances for a range of applications, from residential to commercial to industrial. The Shelley Plus Plug US, shown at the bottom of our graphic here, for our purposes is plugged into a level 1 electric vehicle charger. How the plug roughly works is energy data from the plug itself is broadcasted to Shelley's cloud, and then BED, us, we can request that data and then store it in our own databases. And then when a peak event is discovered by Burlington Electric, we send a request to Shelley's cloud, which then relays it to the plug and turns the plug off during this peak event.
So in addition to Shelley, we're also using a software called Smart Car. So Smart Car is a company that's providing access to a thing called an API, which allows us to connect to the vehicle directly. So most modern cars nowadays come with connected services accounts. So if you have like a Tesla or something, you have an app where you can lock and unlock your car as well as see the charge. So with Smart Car, we can tap into that directly and control the vehicle and get the state of charge.
And then the future of this program, vision it, is users will get their information to Burlington Electric and then will be notified of peak events when they start, when they end. And then if they don't want to participate in the program at this time and they want to charge their cars, that's perfectly fine. They just won't receive the discounted rate that comes with the program. Next slide, please. On the left here is a graph from Shelly Plus Plug USs that are given to a couple of the clients we currently have enrolled into the program. This is an energy usage graph, and the highlighted red rectangles are peak events that we called. And you can clearly see in the graph that the energy usage dips down to 0 during these times.
And then on the right, we have a graph with smart car. So you can see we're collecting the state of charge data, which we can then use to calculate the energy usage during the intervals. In addition to the state of charge, we're also collecting the location data from the car. So for example, if you're on vacation in Massachusetts, you drove down to Boston, we don't want to be controlling your charging when you're not actually in Burlington. So this allows us to decide whether or not we should be turning off your car.
Now, a large amount of the work that we've done this summer with Burlington Electric is creating databases to store all of this data, as well as automating all of our programs and creating proper error handling to keep these automations running smoothly.
And then this will allow us to scale up the program significantly, get a bunch of users logged on, and then as well, the automation will allow it to just happen in the background, and we don't have to be constantly checking what is the status of each of the vehicles. It'll just do it automatically for us. Next slide, please.
And of course, none of this work would be possible without the incredible support of our mentor, Freddie Hall, and of our host organization, the Burlington Electric Department.
We came into this project with fairly minimal Python experience. We've both done coding in other languages, but Freddie was very helpful in working with us with Python and learning data analysis. And it's been also a pleasure to get to see, as two electrical engineers, get to meet with Burlington Electric engineers to see what utilities like from that perspective as well. Thank you.
Great. Thank you so much, Alec and Jack, for kicking off the session with such a great presentation. What we're going to do now is ask you all a few questions about your presentation and encourage the folks joining to type any questions into the chat. First, just wanted to start by saying that this is such a big challenge, flexible load management, as we're electrifying more and more of our systems, and Burlington is very much at the forefront. And so this is a really fantastic and important project that you all have been working on. I was curious if, I know you all have focused on smart cars or electric cars specifically for this. Do you all think that this type of technology, this type of code could translate to other aspects of electricity demand, either in Burlington or elsewhere?
If I'll say it from the Shelly perspective with the smart plug, any high drain or high usage electricity item can be plugged into this smart plug and then monitored with the energy usage. It is completely indiscriminatory to anything that has a 120 volt power source.
And yeah, FLM can be used with really anything on the load side that we can connect to and control. So, you know, modern Internet of Things is making that a lot more accessible as well.
Yeah, so it sounds like it could be a pretty wide-ranging solution across a range of high electricity usage products. So that's fantastic. I was also curious if there were any unexpected insights or lessons that you've gained during the fellowship this summer that you maybe hadn't anticipated at the beginning. So unexpected insights, lessons, challenges that you came across.
A big challenge and a kind of scary thing that I don't think either of us really encountered was working with large data sets. So operating under thousands and thousands of data points that we have to correctly organize, catalog, and then use to make graphs like you saw with that energy usage graph. And I think we're going to take that knowledge with us far into our careers.
Yeah, definitely the unexpected thing was the graphing and the visual interpretation of the data. And then I just see, Sue, your question, and that's how will Burlington crowdsource customers to participate and what type of privacy will they have? So the Burlington's promoting their EV rate on their website. When the level one's up and running, then we'll get that there as well. As far as privacy, everything's secured on Burlington's end, so we're not, you know, just posting the login credentials everywhere. But the smart car in particular, since I've been working with that, I know they have a lot of like consent permission stuff. So when you sign into it, you have to approve a list of permissions. And then if you don't, then we get a notification saying that they didn't sign up. And then they have a whole bunch of cybersecurity stuff as well on their end.
Great. And then just one final question for you all to wrap things up here. So could you tell us more about the next steps? And if anyone is in the Burlington area, could they participate in any kind of pilot program in the coming months, years?
Yeah, I mean, as I said a little bit, as we envision the next steps to be going along with what Alec was saying, it would be advertised on the website through their LinkedIn or any kind of promotional methods that they have. Then if people want to get involved into the program on the Shelley side, I believe BED or Burlington Electric would provide a plug, or some arrangement would be figured out with the company. Then all they really have to do is connect the plug to their internet, send some of the information to Burlington Electric, and how we have it set up is that would instantly get the plug enrolled into the program.
Great. Well, thank you both so much for a great presentation.